children, welcome all for today's science lesson. I hope that you are keeping well and waiting for today's science lesson. Okay, let's start today's science lesson. Changes in matter part 2. That means in the previous part we discussed about the matter and the physical states of matter as solid, liquid and gases. Then we discuss about the changes occur in matter as physical changes and also chemical changes with examples. So finally we discuss about chemical changes in detail. So today we are going to continue that from here. But before starting today's lesson, I would like to mention the competency and competency level that this lesson belongs. This lesson belongs to competency 2. Investigate matter, properties of matter and their interactions to enhance the quality of life. This lesson belongs to competency level 2.4. Uses chemical changes suitably to fulfill necessities in life. Okay, let's see what are the learning outcomes of this lesson. At the end of this lesson, you will be able to state the type of reactions with examples and conduct simple activities to demonstrate different types of chemical reactions. Finally, you will be able to appreciate the importance of chemical symbols, formula and equation as a way of communication. Okay, let's start the lesson. Chemical changes. What chemical changes mean? The changes occur in matters where new substances are formed from the existing substances. Okay, we know during a chemical change, the reactants converted into products. So we can represent it like this. Reactants converted into products. Then what reactant means? The substances taking part in a chemical reaction we consider as the reactants. And product means the new substances produced by a chemical change. So all these things we discussed in the last part. Today I am going to do some experiments relevant to the chemical changes. Okay children, let's start that one. First of all, I would like to show you how magnesium reacts with air. For that one, I got magnesium strip onto a pair of thorns. Then here as a burner I used a spirit lamp. Now I am going to light it. I am going to heat it by using the flame. Okay children, you need to observe it well. Okay, here you can observe it burns with a bright white flame. And look at this. There's a white color powder is remaining. Here. Then here what happens? Magnesium react with oxygen and form its oxide. Okay, I think you observed it well. So now I am going to do another activity relevant to the chemical changes. Okay children, let's do it. that I got potassium permanganate into a boiling tube. Then I am going to heat it under that flame. Now observe it carefully. Okay children, while heating that one, so I am going to take a glowing splinter. So what is the use of a glowing splinter? So in labs we are using glowing splinter to identify the oxygen gas. So how we can identify the oxygen gas? The glowing splinter burns with a bright flame. If not, it reignites. Okay, let's see. Now I am going to insert that glowing splinter into the boiling tube. Again observe it. Here it reignites. Okay children, you observe that the glowing splinter reignites with the product of heating potassium permanganate, that is oxygen gas. So as the same way, when heating potassium permanganate, not only oxygen gas but also some other products are produced. Then let's see another activity relevant to the changes in matter. Here I am going to add magnesium strip into copper sulfate solution. Okay, look at this one. Here I got copper sulfate solution into a test tube. Now I am going to add magnesium strip into it. You need to observe. Here you can observe magnesium react with copper sulfate. That means there are some gas bubbles which are evolved in there. If we keep it for a while, we can observe the color of the copper sulfate get reduces, and also there's a black color substance deposited on the magnesium strip, nearly brown in color. That means magnesium react with copper sulfate. So here there's another reaction occur. I think you observe it well. That means copper sulfate solution, blue in color, it reduces its color when we are adding magnesium strip into it. Okay children, now I am going to do another experiment. Here I got two solutions, one is sodium sulfate and the other one is barium chloride. Both are colorless solutions. Then I am going to add barium chloride solution into sodium sulfate solution. Let's see what happened in there. Okay, you observe it. Here, look at this. The white color substance is foam. That means barium chloride react with sodium sulfate and form a new substance. Okay, I think you got lot of things relevant to the experiments that we did. Now I am going to continue that lesson with the observations that we got from our experiments. In these experiments, we learned there are different chemical reactions occur in matter. In some reactions, what happens is two or more substances are reacting and forming a single compound. That means formation of a new substance by combination of two or more substances. Think about heating of potassium permanganate. In there, what happened? A single compound turned into different products. That's why in chemical changes, turning one substance into two or more substances. So likewise, the chemical changes occur in the nature. If we observe the nature of the chemical reactions, we can divide these chemical reactions mainly into four groups. So now I am going to discuss about that four types of chemical changes. Types of chemical changes. Mainly, we divide the chemical changes into four groups as chemical combination reactions. The second type, chemical decomposition reactions. Single displacement reactions and double displacement reactions. Okay children, now I am going to discuss about these four types of chemical reactions one by one. Okay, let's start. Chemical combination reactions. Let's see what chemical combination reaction means. The formation of a new compound by the combination of elements with elements O, elements with compounds O, compounds with compounds. That means there are some reactions occur where two or more elements are reacting. Sometimes some chemical reactions occur where two or more compounds are reacting. Sometimes the reactions occur by reacting elements with compound, and finally they form a single product. During a chemical reaction, when one compound is formed, so we consider that type of reaction as the chemical combination reactions. Okay, let's discuss about the combination reactions with examples. Look at this picture. In here, the reaction between magnesium and nitrogen is given. That means magnesium react with nitrogen and form a single product, magnesium nitride. The two reactants are reacting and form a single product. That's why this reaction belongs to chemical combination reactions. So likewise, there are some other chemical combination reactions occur. Let's look that. Magnesium react with oxygen and form magnesium oxide, a single product with the two reactants. That's why it is a chemical combination reaction. Another example, carbon dioxide react with carbon and form carbon monoxide, a single product with the combination of two reactants. So likewise, we can take some other examples. Hydrogen react with chlorine and form hydrogen chloride. So I think it is clear to you. When chemical combination reactions occur, a single product is produced. So now I am going to show you a common formula for the chemical combination reactions. Look at this one. A react with B and form AB. So if you remember that common formula, it is easy for you to remember about the chemical combination reactions. It is also given by using that figure. A, B and AB. Okay, it is clear to you. Now let's discuss about the second type of chemical reactions. Chemical decomposition reactions. Chemical decomposition reaction means the decomposition of a compound giving other simpler compounds or elements with compound. Think about heating potassium permanganate. We use only one reactant, and after reacting that one, there are number of products are produced. So likewise, in chemical decomposition reactions, only one reactant used up and forming different products. Okay, now let's see some examples for the chemical decomposition reactions. Look at this. Hydrogen peroxide. It reacts and forms water and oxygen. A single reactant converted into number of products. That means decomposition of hydrogen peroxide. It belongs to the decomposition reactions. Now I am going to explain about some other examples relevant to this type of chemical reactions. Heating potassium permanganate. So we discuss about that one. When heating potassium permanganate, it produces potassium manganate, manganese dioxide and oxygen gas. That means a single compound converted into number of products. Look at this one. Calcium carbonate. When we heat calcium carbonate, it forms calcium oxide and carbon dioxide. Here also a single reactant converted into number of products. Okay, look at this example. Silver oxide. When heating silver oxide, it forms silver and oxygen gas. Here also a single reactant converted into number of products. That's why we know in decomposition reactions, a single reactant converted into number of products. For these reactions also, we can make a common formula. Okay, look at this slide. AB, that is the reactant. A and B are the products. The single reactant converted into number of products. This is the common equation for chemical decomposition reactions. So it is easy for you to remember about chemical decomposition reactions. Let's move to the next type of chemical reactions. Single displacement of reactions. That means the reaction in which an element displaces another element in a compound occupying its place and forming another compound. That means if we consider about some elements, they can react with some other compounds and displace another element present in the compound and forming a new compound. So we can take the reaction between magnesium and copper sulfate as one example for single displacement reaction. Now I am going to explain about this one by using another example. Look at this one. react with copper chloride, what happens? Zinc take the place of copper and form zinc chloride and displace the copper. That's why we can take this reaction as single displacement reactions. Let's see some other examples for this type of chemical reaction. Magnesium react with copper sulfate and form magnesium sulfate and copper. Copper is displaced by magnesium. Look at the next example. Magnesium react with hydrogen chloride and form magnesium chloride and hydrogen. Here, hydrogen is displaced by magnesium. Look at this one. Zinc react with copper sulfate and form zinc sulfate and copper. Here, zinc displace copper and form zinc sulfate. Likewise, the reactions occur where an element react with a compound and form another compound by displacing the element present in that compound. Now I am going to show you the common equation for single displacement reactions. Look at this one. A plus BC and form AC plus B. Here what happens? A displace B and form in another compound. In that way, the elements react with compounds and form in another compound. That's why this type of reactions we can take as single displacement reaction. This is the common formula of it. Now I am going to discuss about the last type of chemical reaction. Look at this, children. Double displacement reactions. What double displacement reaction mean? The reaction in which an element or radical contained in a compound is exchanged with an element or radical in another compound. Think about the experiment that we did where barium chloride react with sodium sulfate. In there you got to another product. So here also that double displacement reaction occur. So I am going to explain about that one by using example. Look at this one. Here the reaction between magnesium oxide and calcium sulfide is given. These are the products. Magnesium sulfide and calcium oxide are the product. Here what happens? Magnesium oxide react with calcium sulfide means magnesium react with the sulfur present in that compound and make magnesium sulfide. And calcium react with oxygen present in the compound and form calcium oxide. The two elements are displaced and form into another compound. That's why we can consider this reaction is a double displacement reaction. Now let's see some other example for this type of reaction. Barium chloride react with sodium sulfate and form barium sulfate and sodium chloride. Another example, ferrous sulfate react with sodium hydroxide and form ferrous hydroxide and sodium sulfate. Look at this. Calcium chloride react with sodium carbonate and form calcium carbonate and sodium chloride. If you observe these three reactions, you can observe what happened in there. Two reactants are reacting and forming new products where the element and the radicals are interchanging. So likewise, if the reactions occur in this manner, we can consider them as double displacement reaction. Now I am going to explain about the common equation for double displacement reaction. Look at this, children. AD plus BC, AC plus BD. So here also the two compounds reacting and two products are formed. Look at this, how the elements and radicals are interchanged with the symbols. So in this manner, so the reactions occur. Now you got an idea about the four types of chemical reactions. Now I am going to continue the lesson with the informations can be obtained by using balanced chemical equations. In part 1 of this lesson, we discuss about how to balance in a chemical equation by using the inspection method. Today I am going to discuss about the informations that we can get from balanced chemical equations. As a balanced chemical equation, as an example, here I got the reaction between hematite and carbon monoxide. When hematite react with carbon monoxide, they form iron and carbon dioxide. So this is the balance equation. Look at this one. Here two iron atoms are present and in the product side two iron atoms are present. Then iron is balanced in both sides. Here 3 oxygen atoms and in carbon monoxide also there are another 3 oxygen atoms. Total oxygen atom present in the reactant side is 6. And look at the product side. In carbon dioxide 2 oxygen atoms are present. It multiplied from 3, that's why there are 6 oxygen atoms present in the product side. In reactant side 6 oxygen, in product side 6 oxygen atoms. That's why oxygen also balanced. Look at carbon. In carbon monoxide 3 carbon atoms. In product side, in carbon dioxide 3 carbon atoms. That's why the carbon atoms also balance in both sides. It is clear to you. Now I am going to explain about the informations that we can get from that balance equation. By using the balanced chemical equation, you can get the amount of moles which are react to form the product. Look at this one. Here 1 mole of hematite react with 3 moles of carbon monoxide and form 2 moles of iron and 3 moles of carbon dioxide. It is one information that we can get from balanced chemical equation. Look at this, children. So you know about the relative molecular masses. How to get the relative molecular masses with the use of relative atomic masses. Here I got the relative molecular masses of the compound by using their relative atomic masses. Hematite relative molecular mass is 160 grams per mole. Carbon monoxide relative molecular mass is 28 grams per mole. Iron relative atomic mass is 56 grams per mole. Carbon dioxide relative molecular mass is 44 grams per mole. If we know the relative atomic masses and relative molecular masses, we can find the amount of mass of the compounds or the element which are used for the chemical reaction and which are produced by the chemical reaction. Look at this one. Here, to get the mass of hematite, to find the mass of carbon monoxide, we multiply relative molecular mass of carbon monoxide from number of moles. 28 grams per mole multiplied by 3 moles. Then, to find the mass of iron, we multiply 56 grams per mole into 2 moles. As the same way, we can get the mass of carbon dioxide by multiplying 44 grams per mole from 3 moles. Look at these answers. 160 grams. Here, 84 grams of carbon monoxide, and they produce 112 grams of iron and 132 grams of carbon dioxide. Okay children, I think it is clear to you. If you are writing a balanced chemical equation, we can find the amount of moles of reactants and the product of the chemical reaction, and also we can find the masses of reactants and products. Now I am going to give you a simple question by using that thing that you learn. Okay. Look at this question. Sodium react with water and form sodium hydroxide and hydrogen gas. The first one, so you need to write the balanced chemical equation for the above reaction. And the second question, find the mass of sodium needed to obtain 200 grams of sodium hydroxide. Okay, try to do that one. I will help you. The reaction between sodium and water. Sodium react with water and form sodium hydroxide and hydrogen. So I used the chemical formulas of sodium and water. Sodium represented by Na, water represented by H2O. Then the product is sodium hydroxide, NaOH, and hydrogen gas H2. This is not the balance equation. Now I am going to balance that one by using the inspection method. So you know about that. So how to balance the chemical equation? So we need to balance the number of reactants and the number of products. Here one sodium atom, and in the other side also one sodium atom. That's why sodium atoms are balanced. Then look at this one. In hydrogen, 2 hydrogen atoms are present. But in the product side, 1 hydrogen atom in sodium hydroxide and 2 hydrogen atoms in hydrogen gas. That means total hydrogen atoms present in the product side is 3. In the reactant side 2, in the product side 3. Now it is not balanced. Now I am going to balance it by putting number 2 in front of sodium hydroxide. Now look at that. 2 hydrogen and 2 hydrogen. All are 4 hydrogen atoms in the product side. In reactant side, 2 hydrogen. Now look at this one. Here I put 2 in front of water. Now the hydrogen atom present in water is 2 into 2, 4 hydrogen atoms. Now the hydrogen atoms also balance. Here 4 hydrogen atoms. Here 2 plus 2, 4 hydrogen atoms. That means hydrogen atoms are balanced. Now let's see. Here if we put 2 in front of sodium hydroxide, the number of sodium atoms in the product side converted into 2. That means 2 sodium atoms present in the product side, and to make it equal with the reactants, here I put 2 in front of sodium. Now here 2 sodium atoms, in product 2 sodium atoms. Now sodium atoms also balance. Let's check it. 2 sodium atoms, here 2 sodium atoms. Here 4 hydrogen atoms, in product side 2 hydrogen and 2 hydrogen atoms, and all are 4 hydrogen atoms. Here 2 oxygen atoms, and the product side also 2 oxygen atoms. Now it is clear this is the balanced chemical equation for the reaction between sodium with water. Now let's move to the second part of that question. Here I took the balance equation. Then I am going to explain about the details that we can obtain from that balance equation. According to the balance chemical reaction, we can find the number of moles which are reacted to make number of products. 2 moles of sodium, 2 moles of water, 2 moles of sodium hydroxide, and 1 mole of hydrogen. These are the relative molecular masses of that compound. By using the amount of moles and relative atomic masses and the relative molecular masses, we can find the mass of the reactants and the product. For that, I multiplied the relative atomic mass from the number of moles. 23 grams per mole into 2 mole means 46 grams. Then 18 grams per mole into 2 moles means 36 grams. Then if we consider about the product, sodium hydroxide, 40 grams per mole into 2, that means 80 grams. Then if we consider about the hydrogen gas, 2 grams per mole into 1 mole, that means 2 grams. So it is clear to you. By using the balanced chemical equation, we can find the mass of the reactants and also the mass of the product. Now look at the question. In the question, they ask to find the mass of sodium needed to produce 200 grams of sodium hydroxide. Okay, now let's find the mass of sodium needed to produce 200 grams of sodium hydroxide. This is the balance equation. According to the data that we get, 46 grams needed to produce 80 grams of sodium hydroxide. Then to find the mass of sodium need to be produced, sodium hydroxide can be found in this manner. Mass of sodium is equal 80 grams. To obtain 80 grams of sodium hydroxide, we used 46 grams of sodium. That's why to get 200 grams of sodium hydroxide, what is the amount of sodium needed? 46 divided by 80 and multiplied from 200. Then we got the answer as 115 grams. That means to obtain 200 grams of sodium hydroxide, we need to use 115 grams of sodium. I think it is clear to you. Am I correct, children? Okay. In this manner, you can find some informations relevant to some chemical reactions. So I think it is clear to you. This is the end of today's lesson. So I am going to summarize the things that we learned today. First we discussed about the different types of chemical changes as chemical combination reactions, forming a single product by combining two or more reactants. Then we discuss about the chemical decomposition reactions. That means a single reactant converted into number of products. Then we discuss about single displacement reaction. Displacement of one element present in a compound by using another element and forming new products. Then we discuss about the double displacement reactions. That means an element or radical present in a compound react with another element or radical present in a compound and forming new products. And also we discuss about some example for these four types of reactions. Finally, we discuss about the informations that we can gain from balanced chemical equations. That means there are different informations can be obtained by using the balanced chemical equation. So we did some examples for that one. Like that, we discussed about the chemical changes in detail. I hope that you enjoyed today's science lesson. To get more information about the lesson, the thing that you need to do is do the exercises. So in your textbook, there are a lot of exercises relevant to this part. So go through that one. Find some exercises relevant to this lesson and do them and get more ideas about the way of balancing the equations to find some information relevant to the balance equations like that. Okay children, let's meet on another day with the third part of this chemical changes in matter. Goodbye.